Let's see. Good morning. Oh, wait, it's afternoon. Good afternoon. Welcome to Tom's Hardware. I'm Jared Walton. We've been off for, it feels like more than a couple weeks. Last week was Thanksgiving. This week is not. And next week, of course, is AMD's RX 7900 series launch, so I'll definitely be back for that. But in the meantime, I've been trying to do some AI benchmarks, and that's harder than you might think. So Stable Diffusion, based off of DALL-E, I believe. They're both AI image generators. So you give them a text description, and off it goes, doing some AI magic, and the results are quite impressive at times. Other times they look horribly disfigured and weird and whatever, but the thing they're doing is they're doing a lot of number crunching on your graphics card. You can try and do it on a CPU, and it's like super slow by comparison to graphics cards anyway. So before I get to the benchmarks results, because I've really only got one result slide, running Stable Diffusion. I could do more, maybe. But before I get there, I want to talk about some of the issues. So, first off, you got to get Stable Diffusion up and running. It uses PyTorch, Python, a thing built around AI and such. It's quite commonly used. Builds off of TensorFlow, I think. And most of it is optimized to run on Nvidia CUDA. And so there's these workarounds to get CUDA running on AMD instead. And I think there's workarounds to try and get it running on Intel's One API. I haven't even tried to get Intel running. I've sent out a request to Intel directly to just say, hey, can you help me out here? Got any good instructions? Because the instructions I found for AMD, I eventually got it working. But I don't know that it's actually working properly. Let's just put it that way, because it's quite slow by comparison to Nvidia. And maybe it's that Nvidia's hardware is better. More likely is that the way I'm running it or the tuning of the software is to blame. Anyway, there's a guy out there. So Stable Diffusion, made by huggingface.co. It's open sourced, and I believe they built it off of CUDA. And then there's a guy out there named Automatic1111, and he built a web user interface for it, which works like a lot more. It makes it a lot more convenient to do some testing than the command line interface, and it gives you some more options. So chief among them, for me, I wanted to be able to do a lot higher resolution than the default 512 by 512. Stable Diffusion 2 just came out recently. I think Hugging Face added support for higher resolutions with Stable Diffusion 2. But anyway, so I grabbed this Automatic 1111, and the instructions for NVIDIA are really easy. Like, you download this thing from GitHub, and you run the webui.bat, and it basically downloads some stuff that it needs. There's a few, maybe, I don't even remember now. It's been like a week, but it was relatively simple to get up and running. Performance looked good. And then there's this Transformers engine. I think it's Transformer engine. It's called Xformers. You can enable that on NVIDIA, and it works under Windows, and it all went great. And then on the AMD side of things, it's like, yeah, you might need to use it under Linux. There's this guide to getting it working under Windows, but the guide is actually not for the web UI. I couldn't get the web UI to work at all. And the guide starts with like, hey, here's to get it running natively on Linux. I tried those steps. Running this PC back here is actually running Linux right now on a different SSD. And then it's got instructions for getting it running via a Docker image. And I ended up having to go the Docker image route. So on AMD, I'm doing, I'm booting into Linux, grabbed the latest stuff as far as I could tell, ran it through Docker, and got it up and running. I couldn't get the Docker stuff to work. Transform and roll. I couldn't get the Docker stuff to work under Windows. Someone else noted like it doesn't work under Windows. I don't know if that's absolutely true or if it's just you need to know the right way to get it to run. Let me throw up some pictures though. So this is what I've been generating. My default image. Here, we'll go to this. Not default image. My command prompt is basically post-apocalyptic, steampunk city, and then a bunch of other stuff. And I did tweak that over time, change it here and there, not for the benchmarking purposes, but to just generate some cool images. So I had fun. I mean, like, for being completely AI generated, it's like, wow, that actually looks pretty good. And with the web UI, you can get up to 2048 by 1152 is what I was generating, because that's a nice 16:9 aspect ratio. I don't have to crop anything or whatever. It normally goes in 64 pixel increments, I believe. So anyway, that's the first image. The faces, not so clear. It does kind of look like Borderlands art style. And I suspect like maybe the training data set for Stable Image or Stable Image 2, whichever it was, I don't even know for sure. That maybe it included a bunch of pictures from Borderlands. But anyway, some of them look pretty fun. I think I put in trees and vegetation because at first it was looking a little too brown and sometimes gray and whatnot. Mushroom cities, I don't know, kind of fun. The Lorax meets steampunk. I tried cyberpunk as well. Like I put in post-apocalyptic cyberpunk, and that did not work well. It gave me a lot of neons, but didn't really look very realistic. I like this guy just floating up in the air here. Is that supposed to be some steampunk helicopter? I don't know. Is there a dragon steampunk thing in the background? I don't know. But yeah, so these are the images it's generating. And so here's the thing. So it's built for Nvidia originally, seems to be optimized for Nvidia, and on like the top end Nvidia card, so I've got a 4090, I've got 4080, and those go really fast. The 2048 by 1152, I'm like, yeah, this isn't too bad. I think it took like maybe a minute to generate 3 images at this resolution. I was like, oh, that's pretty snappy. That's not too bad. Some of them look less Borderland-ish, maybe. I like this guy's crystal head in the bottom left corner. I have no idea what that's supposed to be, but the AI did its thing. And I think we're almost at the end of my slides. These trees all look very similar. There's like these caterpillar things, bone caterpillars, kind of look like the, what was it in one of the Avengers movies where the giant flying snake creatures come through the portal. They look a little bit like maybe that. These pseudo steampunk cars with glowing headlights. Those show up in a lot of the images I've generated. And then let's see, the last one. I put in Leviathan on one of them just because I thought that'd be fun. It's kind of chopped off, like it doesn't blend into the background quite right, but I thought that was fun. Giant blue purple Leviathan. So, lots of cool stuff that you can generate. And, I kept my prompt basically the same through my benchmarks so that they're all generating the same scene. I could have set a static seed, which would have given the exact same images every time. But that would have been boring because who wants to generate the same 3 images over and over and over? So part of it, I also put in a high-res fix that you specify a lower initial target. So I did 768 by 512 that then gets upscaled to 2048 by 1152. It does some weird things if you go straight to the higher resolution because its training was based around like 512 by 512 or 768 by 768 images, I think. But there you go. That's the starting point. So Nvidia runs pretty well. I mean, I tested everything from 4090, 4080 down through the whole 30 series. So 3090 Ti down to 3050. And by the time you get to the 3050, I'm like, oh man, this is not nearly as fast as it was on these other cards, which isn't too surprising. Also, memory limitations can come into play. So there's like command line options that you can do, MED VRAM, medium VRAM, or low VRAM to get it to run on less memory. And I tested that on a 3080 something at one point with and without the medium VRAM argument, and it did drop performance like 3 to 5% when using medium VRAM. So, you know, if you have lower memory on your card, that could be problematic. Rurutu, are these using tensor cores? So I think there's two modes. The default mode does not use tensor cores, but if you throw in --x transformers as a command line argument to the web UI version, then it downloads this transformers engine, and I think that does use the tensor cores, which it boosts performance quite a bit. So shall we go ahead and show the benchmarks? So again, disclaimer, AMD's results may or may not be valid here. They're internally valid, meaning when you see the AMD cards, I'm like, yeah, they all make sense. You know, the 6950 is faster than the 6900, and so on down the list. But comparing AMD to Nvidia, which I've got in the slide, probably isn't entirely valid because the AMD performance is going through Docker and it's pretty slow. So, all right, no complaining. These are initial benchmarks. I got it to run, and I know the AMD cards are working because, like, if you feel the GPU while it's running, they're definitely getting warm. It's like when you're playing a game, you can feel that it's heated up, and so I'm like, yeah, they're using the GPU, but all right, enough beating around the bush. Here you go. All right, so you'll see all the Nvidia cards have two scores. The black line is the score without the Xformers command at passed along. So I think those are not doing. I should clarify. They may not be doing the tensor cores, or it might be that they're not doing. I guess the newer cards support more tensor core options, so you can do FP8 and FP16 and BF16. So I don't know which mode they're running in, but it like if it is tensor core based on all of them, and the Xformers just makes better use of the tensor cores, then maybe these results are somewhat sensible. Because, like, if you look at theoretical performance, take the Nvidia card. The slowest card that I tested for now is an RTX 3050, which tensor core compute is still like up to 73 teraflops. And then you go over to the AMD side of things, and the 6950 is only, I guess if it's doing half precision, which I tried to let it do, it's doing 47 teraflops. So even then it would theoretically be slower, but I don't know. I don't have the wherewithal, the knowledge right now to get down to the nitty gritty and tell you how each piece of hardware is being used right now. I do know that it's using the GPU. So this is kind of interesting. You know, you can see 6800, it's not memory bandwidth constrained, since the 6900, 6800 XT, and 6800 all have the same 16 gigabytes of GDDR6 memory. So it's scaling basically with their compute performance. 6950 has slightly faster VRAM, more compute because it's clocked higher. This also works on GTX cards, which I haven't tested yet, but I want to test. And that would actually help me understand better, like, is it using the tensor cores or not? How fast is a GTX 1660 Super? It's on my list. Let's see. So that's and this iterations per second is what the results are expressed in. I did 25 steps with the prompt that I gave it, which is this like lengthy post-apocalyptic high detail blah 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 prompt. And the 25 steps means it does 25 iterations at 768 by 512, which goes really fast on most of the GPUs. And then it does 25 more iterations of this higher resolution upscale algorithm, which takes a lot longer. So even on like the RX 6950 XT, the first pass seems to take maybe 5 seconds. And then the second pass is like a minute and a half, or I think it was even over 2 minutes. It's a lot longer. And I do 3 images each. So it says 3 batches. I don't know if that's the correct term. 3, the batch size is set to 3 or something like that. Let's see, 40. So that I noticed that too, that the 4080 got beat by the 3090 and the 3090 Ti and the 3080 Ti and even the 3080 12 gigabyte. And my only thought there was, like, is it memory bandwidth constrained? And it might be to some degree, because the 4080 only has a 256-bit memory interface, whereas the 3080 has 320-bit, but it's not clocked as high, so it probably ends up a bit less memory bandwidth. But then all the others, the 3080 12 gigabyte and above, have a 384-bit interface. Or maybe the software is currently not tuned for Ada Lovelace as well as it could be. So there's definitely question marks, and that's why this is all preliminary. But yeah, I thought it's kind of interesting, it's fun to play around with. I'd seen the websites, where you could go and do it on a website, and you're like, oh, that's pretty cool. It takes a couple of minutes and it gives you a result. But a lot of those, then they're like, oh, we need you to pay for more points to generate more things. It takes longer, and you end up with a 512 by 512 image, not this 1080p image. So I got it up and running on my own system. That's pretty fun to play with. And my kids were trying to play around with it and giving them misspelled prompts and so on and so forth. But anyway, have you played with Stable Diffusion, any of you out there? Has anyone watching this perhaps gotten it running better on AMD cards? Don't compare your iterations per second to my results unless you're running at the same settings and resolution at the very least, because it scales very poorly as you go to larger resolutions. So keep that in mind. But yeah, the 4080 did not impress in this particular test so far. Anyway, I've got feelers out there. It does go to show, like, these high-end or these new and bleeding edge research things like AI and image generation and that sort of stuff. I think Apple released a statement, or no, Apple released a thing saying, hey, we've created some metal accelerations for AI, and they've got Stable Diffusion running on their M1, M2 hardware now. And one of them, I think they said it ran 19 times faster after their optimizations. So, there's potentially a lot of room, junk in the trunk, that we haven't accessed that could speed up all of these. And it'll be interesting to see where this goes over time. Because right now it's like, okay, so it takes for a fast Nvidia card, it might take 20 seconds to generate an image. For a slow Nvidia card or one of the AMD cards, doing it the way I did it, we were looking at like 2 to 3 minutes at least per image of a high resolution, close to 1080p image, right? But then Apple, I actually had one of my coworkers trying to follow the steps and see if he could get his M1 Pro to run, and I think the the net result was no, he couldn't. So if you want to try it yourself, I'll toss this link in the chat here. So this is what I was using, and take that as you will. And in fact, I'll even give you my full prompts here. Hey, come on, there we go. Sorry, my notepad was complaining. Notepad++ wasn't responding. So this is the prompt I use. There's a positive prompt and a negative prompt supported. So negative, I said things like, hey, I don't want fog, and I don't want it to be dark, and I don't want it to be blurry. And then the positive prompt is the things that you do want. And I have no idea if this prompt is good, but it generated the images that I gave. So if you look in the comments, those are the commands that I gave. So I'll even show, let's see, where was I? So this is where I grabbed the stuff from, if you're just watching along. And this is what I actually posted. So the post-apocalyptic steampunk city octane render. You can take out some of these and it doesn't change things much, but I was Googling and people were throwing things in there. 8K shouldn't matter because we're not rendering at 8K. Exploration, cinematic, realistic, hyper detailed, photorealistic, maximum detail. I mean, you can tell people are like trying to get it through to the AI, like, please do this as a high quality, not blurry rendering. Volumetric light, moody, cinematic, epic concept art, colorful. The parentheses mean emphasize, so I said focused, really focused, wide angle, brightly lit, trees and vegetation, lightning and vines. Not all of them had lightning, not all of them had vines, so some things it doesn't quite get, but it generally does what you ask. And then I emphasized really not blurry or foggy or dark or monochrome. I put sun in the negatives because a lot of the images it generated initially had like a sun in the background. So if I go back here, imagine a bright sun sitting in the middle of the screen, and it would try to cast shadows, but it like bleeds out everything and everything else looks dark. Sometimes you want that effect, sometimes you don't. So that's why it's had no sun, no depth of field. And then the actual settings, I did 25 steps, the Euler A, which is ancestry, I believe, Euler ancestry algorithm, target resolution, then the high-res fixed resolution, denoising of 0.7 is the default, batch count of 3, and then the CFG scale is for how closely you want the AI to try and follow your prompt. You can go from like 1 to maybe 30 or 50, I think 30. And if you do lower numbers, it's more creative, I guess you could call it, which can be good or bad. So, like maybe my clouds were a little creative, right? Anyway, so that's what I ran. It was pretty interesting to poke around at it. I've been looking for good AI benchmarks for a while. Is this a good AI benchmark? As it stands right now, no, it is not. I mean, maybe it is. Maybe AMD is really that bad at AI by comparison, because if you're using those tensor cores to their full potential, maybe this really is how fast the Nvidia cards run. I'm not sure. I mean, like the 40... If you look at the 4080, 4090, obviously it's not pure compute either, because, the 4080 should do a lot better. It's got more compute than the 3090 Ti. It's got less real memory bandwidth, but it does have cache that I would think would still help, but apparently it doesn't. So, yeah, it is what it is, as they like to say. Let's see, questions here. Let's see. Yeah, this is built into the price of Nvidia cards. Yeah, they did. I mean, CUDA is a big deal for Nvidia, and like in the AI space, I think people have like a love-hate relationship with CUDA. Like there's developers who are like, yeah, it's so much easier, and I've talked to people that are like, oh, I hate CUDA, but it's pretty ubiquitous in comparison to ROCm or what is it, One API or OpenML or whatever. Maybe the others will catch up. I mean, Nvidia kind of got bootstrapped on CUDA development by the U.S. government and other big spenders on supercomputers because they wanted a better language, and so they got millions, hundreds of millions of dollars that funneled into creating CUDA, and now with the AMD supercomputers coming out, they're getting a lot of funding to help create ROCm and these open source CUDA alternatives. OpenCL has not really caught on as much. But maybe ROCm will do better. That's how the AMD cards run. They go through there's a translation that converted the CUDA stuff into ROCm compatible, I think. I'm not totally sure on that, but yeah. Any interest in investigating old AI accelerator cards like the Tesla M40? I mean, I would test them if I had it, but the problem is, like you say, they don't cost that much, but I don't buy most of the hardware I test. It gets sent because I'm a hardware reviewer and we're a big enough site. So, hey, if anyone, Nvidia, if you watch this and you want to send me older Tesla cards or even newer cards, I'd love to have an RTX 6000 and an A6000. Yeah, just send me so Nvidia has announced their latest and greatest Ada Lovelace based, no longer called Quadro, but they're professional cards, and the RTX A6000 was the Ampere version. The RTX 6000 without the A is the Ada Lovelace version, and you can still pick up the A6000 for $4,650 is the official MSRP, I guess, from Nvidia. The 6000 Ada isn't necessarily for sale from Nvidia, but you can find it online. They're listing MSRPs of $10,000. I don't know. All right. Cash is king. Which cash? You put an SHE. I don't know. But yes, both kinds of cash are king. If you've got the money for a faster card, it will boost your performance. If you've got the money if you've got the extra cash for your chip, that can help too. All right, that's about it. All right, I don't know. Anything else we should talk about? AMD RDNA 3 launches next week, right? It's launching on the 13th. So 7900 XTX, 7900 XT coming out soon. And they have improved AI accelerators. I'm still trying to get down to the explanation of what those are doing. Are they actual tensor cores? I think they're doing matrix operations, but I think they're sharing hardware with the GPU shaders. But I haven't gotten a clear explanation on that, and I haven't gotten, AMD doesn't make any specific statements about, hey, our int 8 teraops is this number, which, it should be based off your clock speed and how many matrix ops you can do. They also support BrainFloat 16, BF16, which is used for AI, but I still don't have a clear indication of, well, how fast is your BF16? And even if it offers comparable performance to Intel's matrix extensions or maybe even tensor cores on Nvidia, you still need software optimized to use these new instructions, and that might take some time as well. But it's a big field, and people have talked for 4 years about how Nvidia wasted a lot of die space implementing tensor cores on consumer RTX hardware, and of course their plan was not to just give it to consumers. They wanted it for their professional cards, so like Rurutu was saying, it's built into the cost. They spent a lot of money research and development on this. They're pushing it. They want people to use it. And there's definitely some impressive stuff being done in the world of AI. And part of that was bootstrapped by their consumer cards that sold millions or tens of millions of cards over the past 4 years that had Tensor cores. So AI art is just one of those things. It's being used for lots of stuff, for text to speech, for processing speech in general to get speech to text, transcribing. Lots of cool stuff happening with AI, medical research, weather, all these things that, like weather prediction has gotten a lot better, and it's both because their models, AI trained models, are better, and because they're collecting more data. Like there's people every day that I believe go out there and launch weather balloons to collect atmospheric data. Kind of cool stuff. That's why our weather models improve. But yeah, Open and Aracam lagging in relation to CUDA. Yeah. I mean, it's this chicken and egg thing. Sometimes being first is given Nvidia a huge advantage, and people are entrenched in what they're doing, and getting them to switch, even if ROCm was better or one API was better, how long would it take for people to migrate? If you've got a supercomputer built off of Nvidia GPUs, are you going to switch it to an open standard and re-implement it all for the supercomputer? No, you'll stick with what's already there. The new supercomputers like Frontier and in a year and a bit, El Capitan, they'll be built around ROCm, I guess. And so maybe adoption will improve there. We'll see. I think that's about it. Any final questions? Otherwise, I'll go back to prepping for... Oh, this is cool. I've got toys. I've got toys for next week. Next week? No, 2 weeks. Just a 1 terabyte SSD. I bought this on Black Friday. $20 Razer mouse. But this is more important. AMD Expo memory. And where's my other one? Oh, there you go. Not AMD Expo memory. We're getting set up. The GPU test bed back there, he's getting an upgrade. And then I got to find a second upgrade because Ryzen 7950X is in the house. And Core i9-13900K is in the house. And I have to retest everything that we want to show benchmarks. And so probably for the AMD 7900 series launch, my intent is to have benchmarks on Ryzen 7950X and 13900K, as well as the 12900K, because that's my existing platform where I've got all my existing benchmarks. But I also know, because I've run the tests lately, is that 2 of my benchmarks the results are, well, they're all invalidated. They're broken. Things changed. So Total War Warhammer 3, I need to retest pretty much everything that I want to show in the charts. All the old results were internally consistent, right? But new drivers, new game updates from both AMD and Nvidia, and I think Intel, have altered its performance quite a bit in some cases. And then Forza Horizon 5 got a patch that dropped 2 weeks ago. It enabled DLSS 2 and FSR 2 and temporal anti-aliasing in experimental mode. And it did some other stuff too, but it changed a bunch of things. And going back and retesting it, like the 4090, I got 260 frames per second roughly in my initial testing back in October. And when I retested the new version, that was at 1080p medium, it's down to like 212 frames per second. The higher quality modes didn't change as much, but they did change enough that I'm like, oh, great, everything's changed. So as long as I'm going to be retesting things, I may as well retest on a new platform, new system. Anyway, it's going to be, yes, as Raphael Hassel says, good times, good times. Yeah, so the intent, just to go over that again, I want to test the AMD cards on AMD just to see like how much benefit there is to running all AMD. AMD will tell you that Smart Access Memory, SAM, they're customized, built on top of PCI Express resizable base address register bar, rebar. They'll say that SAM is better with an AMD CPU and platform and an AMD GPU, and that they get more like 10 to 15% gains on their system, whereas on Intel with an AMD GPU or an Nvidia GPU, that the gains from rebar are not as significant. And I think they're probably right there. So it's going to be interesting to see. So we'll check back in a couple weeks, and hopefully we'll have the reviews all done, and hopefully I don't die trying to get the reviews done. All right, everyone. And while I'm here, I've got other things that I still need to review. ARC A770. What's special about this ARC is that it's the 8GB A770. So that'll be fun. Got the AMD platform Tai Chi for the X670E. I mean, we're going all out. I've got some PCI Express ATX 3.0 power supplies as well, but I don't want to use the 12-pin native adapter, 16-pin, because I swap GPUs all the time, and I do not trust those pins for the 16-pin to swap as often as I do. In fact, even on this 12900K test system, it's got 8-pin power connectors for the graphics cards, and I have installed those and uninstalled them, clipped in, clipped out so many times in just a year that I wouldn't say they're loose, but if you have a brand new 8-pin connector and you snap it into an 8-pin socket, it feels, it's a little stickier than this one has become. And so I'm like, yeah, that's in like 9 to 10 months of use that there's a noticeable drop off in terms of how the 8-pin PCI Express power connector feels. And I'm like, I can only imagine if I were installing and disconnecting the 16-pin connectors like I do the 8-pin connectors for a year straight, that something is going to go wrong. So I'm just going to keep using 8 pins in the adapters. What do we got, Mike? Poster board display at GTC. How can any competitor to NV compete across those app segment strongholds? Yeah, I think I know what you're talking about. At the GPU Technology Conference, like, it's all these AI research papers, and maybe it's not all AI, but it's professional graphics research and stuff. And like, when you see, if you've ever go to a GTC, like, there's just hundreds of papers that are all developed using CUDA and Nvidia GPUs. And my experience is that, like, as bad as Nvidia's lead is in the consumer segment, talking GeForce versus Radeon and ARC, if you go over to the professional and the research and the AI side, like, it's not 80%, 20% Nvidia, meaning 20% AMD. It's more like 95 to 99% Nvidia is how it feels. It's a huge gulf, and you have to get all these people who have already learned CUDA and teachers who are teaching CUDA because that's what they've learned. You have to get them to leave all that behind and do something else. So yeah, it's going to be, it'll take time if AMD ever catches up, if they can catch up. I mean, they can, but it's not going to happen overnight. I'm certain specialized offload as a replacement tech will overcome NV General all-purpose. Yeah. Yeah, and like ROCm, I think ROCm's one of their big selling points. It's like they have a translator that will convert your CUDA into ROCm, something like that, or maybe it's HIP. And like, would you want to write code for one architecture and then trust a translation layer to extract maximum performance on a different architecture? Like, people have tried that a lot of times over the year. You know, going way back, we've got the alpha, the DEC alpha processors back in the day. They tried to do x86 support through binary translation, and it didn't really. It worked, but it was never as fast as running on native x86. Oh, there we go. Yep. Nvidia makes a lot of money. They're worth more than Intel now, and it's interesting that they've made all this money, because so far the supercomputer segment for the major supercomputer installations has been largely shifting away from Nvidia for the last couple of years. You know, like if you look at what's coming, Aurora, Frontier, and El Capitan for the US, you've got AMD on AMD, AMD on AMD, and Intel on Intel. Whereas, like, prior to the last 3 years, almost everyone was moving to, like, A100 and Nvidia GPUs. And that has stagnated a bit, maybe? All right. Thanks for watching, you guys. Check in next. So it won't be next week. It will be in 2 weeks. December 13th is when AMD RDNA 3 launches, and I fully intend to have a review. We'll see how much I can cover of performance in other ways. I mean, like, given I've got AMD GPUs running through Linux right now, I wish you could see that screen. It's running Ubuntu 20.10, I think is the version, which is actually quite useful. I mean, like, if you've never tried Ubuntu, it's pretty amazing how good it's become and how easy it is to get up and running with it. And you can do just about anything you want to do, but I don't know, maybe I'm not the good example because I'm a total computer nerd and I've used Linux in the past, and I did software development on Linux way back in the day, back in the 90s and into the aughts. But yeah, exciting times ahead. I agree, Mephisto. Exciting times, and then, you know, we'll see what happens next year. We've also got, you know, other cool things happening. Portal RTX launches next week. I guess that'll be next week's show. We'll talk about Portal RTX and see how it actually looks and performs. I'm still not. The jury is still out on this DLSS 3 frame generation, and Portal, I think, might be a good. I mean, it's still a puzzle game. Maybe not quite as fast-paced as some other games, but I'm curious. Like, I've seen some demonstrations of where DLSS 3's frame generation breaks. But, you know, in actually playing games with DLSS 3, I don't notice the breaks unless I'm trying really hard to find them. Kind of like DLSS 2. Like, there's a scene in Hitman 3, where if you turn on DLSS, that you can get these ghosting effects, and it to me it's a bug. Like, that's one of the things they've worked on trying to improve with DLSS over time. But yeah, so frame generation, I think it totally breaks down in some edge cases. How common are those, and how do games running at 60 frames per second with frame generation feel compared to, you know, 60 frames per second without frame generation, because latency should be an issue. All right, guys, have a good week. Guys and gals and others, have a good week, and we will see you next time. And we'll talk about more exciting stuff. Happy holidays.